Hi everyone, so today I want to talk about heat capacity and latent heat and why so many students in O-level physics always mix up this concept and get these questions wrong. And I'm going to give you a very simple way to understand these two concepts. And once you understand this concept, this topic becomes easy. I know many students, they always find thermal physics hard just because they don't understand this thing. So let's break it down in this video. So I'm Jing from the A1 Physics. I teach many students in Singapore O-level physics. So I'm going to go through what this concept actually means, and as well as after this, we're going to try to attempt and apply our knowledge to this TYS question. Now, first of all, when do we use heat capacity and when do we use latent heat? Right, so very simple. We use heat capacity when we are increasing the temperature of something. So example, you're heating up water from 20 degrees water to 40 degrees water, right? The energy needed, you calculate using the heat capacity. Whereas for latent heat, we use latent heat when we're calculating a change in state, right? So for example, when you melt ice from 0 degrees to 0 degrees water, right, you're melting the ice, you use latent heat to calculate. So the formulas we know is E equals to big C theta. Big C refers to the heat capacity and small c refers to the specific heat capacity, right? For latent heat, we use E equals to L. Big L refers to the latent heat and small l refers to the specific latent heat. Now, many students stop over here. They just memorize the formulas and they just try to write down the formulas in the question, right? Without truly understanding what does heat capacity and specific heat capacity actually mean. And that's why many students find thermal physics difficult even though they technically memorize all the formulas. So I'm going to show you the simplest way to understand this, and it will make thermal physics so much more easier. Now, the heat capacity of object is the energy needed to heat the whole object by 1 degree Celsius, whereas the specific heat capacity is the energy needed to heat 1 kg of the object by 1 degrees. Now, this one is not the official definition, it's just an easier way for you to understand, right? So let me show you an example over here. Let's say I have an object over here, right? I have a 4 kg object over here. Now, how much energy do I need to heat up the whole object? That is the heat capacity, right? Let's say I need 400 joules of energy to heat up the entire object. So the heat capacity of the object, to heat up the entire object by 1 degrees, right? So that's the heat capacity, 400 joules to heat up the whole object by 1 degrees. But the specific heat capacity is how much energy I need to heat up just 1 kg of the object. That is the specific heat capacity. So can you see that over here, the heat capacity depends on how big the object is, right? The more mass the object has, the more energy you need to heat up the whole thing. Whereas for specific heat capacity, it doesn't depend on the mass, right? It's just per 1 kg. This one is a fixed number. So the same material will always have the same specific heat capacity, but depending on the size, if it's bigger, it can have a different heat capacity. So that's the simplest way to understand this. Right now, let's talk about latent heat. Now, the latent heat of the object is the energy needed to melt the entire object, right, the whole object. And the specific latent heat of the object is the energy needed just to melt 1 kg of the object. Right now, again, this is not the full definition. Obviously, there's melting, there's boiling, there's condensing, freezing, but just to make it simpler, we just focus on melting over here, right? So let me show you what I mean. Imagine we have a block of ice over here. We have a 4 kg block of ice. I want to melt this entire block of ice into water, right? The energy needed to melt the entire 4 kg into water is the latent heat, whereas the energy needed to melt just 1 kg of the ice, I just want to melt this 1 kg, is the specific latent heat, right? So can you see that if I need 400 joules to melt the entire block of ice, I only need 100 joules to melt the smaller block of ice. Okay, so can you see the relationship between heat capacity, specific heat capacity, latent heat, and specific latent heat? Now that we understand this, let's go and try this O-level physics TYS question. Now, a block of copper is at room temperature. Which row describes a smaller block of copper at the same temperature? So we can see over here, the energy needed to heat up the bigger block is obviously more than the energy needed to heat up the smaller block. Right, the bigger block got more mass, so you need more energy to heat up the whole thing. So smaller block actually has less heat capacity, right? Whereas for specific heat capacity is the energy needed to heat 1 kg of the object. So we can see even if you are bigger or even if you are smaller, right, the energy needed to heat up just 1 kg of the object is the same because they are both made up of the same material. So the idea is that the specific heat capacity is actually the same for both blocks. And lastly, we talk about internal energy. Now, we really got to have a strong understanding of what does temperature means. Right, temperature means a measure of the average kinetic energy of the particles. So the keyword over here is average. Both blocks have the same temperature. Means that on average, both blocks have the same kinetic energy. Right, the particles in the blocks, on average, they have the same kinetic energy. But because the smaller block has less particles in total, right? The smaller blocks have less particles in total. Even though on average the energy of each particle is the same, the smaller block got less particles. So in total, the smaller block will have lesser internal energy in total. So that's why the answer for this question is A, right? And honestly, this question, most students cannot get this question because they lack the basic understanding of what actually is heat capacity and temperature. So I hope this video helped you, right? Once you understand this, thermophysics really becomes very easy. And if you want to get tutored by me for physics, just go ahead and WhatsApp the number around the screen and I'll send you the details. Right, good luck and all the best for thermophysics.